Now, we know it says create a table and then graph and explain if the quantities are proportional. And I've already graphed it for you, but let's look at the quantities here. We're going to do, and I'm going to stop here and download. No, I'm not. I'm going to keep going. It's over 15 minutes. Okay, so I'm going to do hours over gallons, so that's going to be 1 over 6, 4 over 4, 7 over 2, and 8 over 0, and up here it's 0 over 8. Okay, these are the rates of change, or the, or not the rates of change, I'm sorry, the constant of proportionality, y over x, and they are not equal, so these ratios are not proportional. We can look over here and tell because we don't have a straight line, and it doesn't go through the origin. Okay, so are they proportional? In the graph above, no, because not a straight line. Or doesn't go through the origin. You can use either one. What would be the rate of change? Well, we could go from point to point, but it's changing every time, okay? Because when I go from this point to this point, I go down, and then I go to the right so much. And it's hard to count how much, but now I'm going down even more and right, okay? And then I'm going to go down. They're all not the same. So what would be the rate of change? Can't tell. It's not constant. And it's not constant because it's not a straight line. Is the rate of change constant? No, because it's not a straight line. What do you notice about the rate of change and the constant of proportionality? Okay, the constant of proportionality, there is none. There's no rate of change, and there's no constant of proportionality. I'm going to call it COP, because they're not proportional and they're not linear. So when it's nonlinear, it's not going to be proportional, and it's not going to be linear. It's not going to be a constant rate of change. Okay, so let me redo that. Okay, so not a constant rate of change goes with the idea that it's nonlinear, and not a constant of proportionality goes with the fact that it's not a proportional relationship. Okay, so those go together. All right, so let's look at example 4. Now, right now, I can see it's not linear. And it does go through the origin, though, but it's not linear. So before I even look at the relationship in the table, is the relation above proportional? We know it's not. So if so, what is it? There isn't one. Okay, is the relation above linear? No. If so, there isn't one. Just like this one up here. Okay, so what's important to note, okay, characteristics of the constant of proportionality, okay, if you have a constant of proportionality K, then the relationship is a line that goes through the origin. Okay, characteristics of a constant rate of change, okay. There's also, it's going to be a line. The relationship. Instead of saying is a line, I'm just going to say is linear. That means the same thing. Is linear, and those of you who have Mr. Wildbaker know he says linear, which is wrong. Relationship is linear. Does it go through the y-axis? Does it go through the origin? It only goes through the origin if it's proportional, okay? But if it's not proportional, then there is a constant rate of change, but it's not proportional. All right, so we're finished, and you can go back and rewind anything, and my lights just went off, so that's perfect timing.